In Chapter 17, we focus on the correct way to interpret probability. For instance, we all know that the probability of observing heads when flipping a fair coin is 1/2. What exactly does this mean? By the end of the lecture, you should be able to properly explain the meaning of this statement. These are the concepts we will discuss today: the idea of probability, myths about chance behavior, and personal probabilities. One way of understanding chance is to think about what happens when an experiment is performed several times. This is because random phenomena are unpredictable in the short run, but have a more regular pattern over time. For instance, everyone knows that there's a 1/2 chance of observing heads when flipping a fair coin. One of the goals of this section will be interpreting what this means. For instance, does this mean that there should be exactly 5 heads and 5 tails if we flipped a coin 10 times? Does this mean that our next flip should be tails if our previous was heads? It turns out that both of these interpretations are incorrect. Let's discuss some terminology. First is the term random. For our purposes, we will think of random events as those that are unpredictable in the short run, but exhibit some type of order in the long run. Random is not to be confused with haphazard, which means lacking any principle of organization or structure. In general, we call a phenomenon random if individual outcomes are uncertain, but there is nonetheless a regular distribution of outcomes in a large number of repetitions. The probability of any outcome of a random phenomenon is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. So probability is a number between 0 and 1 that tells us how frequently something should occur in a long series of trials. For instance, an outcome with probability 0 should never occur. An outcome with probability 1 should always occur. And an outcome with probability 1/2 should occur about half the time. As an example, let's refer to the coin tossing experiment. The probability of heads is 1/2. So the proportion of heads we observe should be close to this value in a long sequence of trials. For instance, Count Buffon performed this experiment in the 1700s. He flipped a coin 4,040 times, resulting in 2,048 heads, which gave a proportion of 0.5069. In 1900, Karl Pearson performed the same experiment, this time performing 24,000 tosses, which yielded 12,012 heads and a proportion of 0.5005. Let's discuss some common myths about chance behavior. Recall, probability tells us that randomness is only regular or predictable in the long run. It cannot say what will happen in the short run. For instance, suppose we tossed a fair coin 6 times. Which of the following outcomes is more likely to occur? Many people think that the first outcome is more likely because the second doesn't look random. However, both are equally likely to occur. That heads and tails are equally probable says only that about half of a very long sequence of tosses will be heads. It doesn't say that heads and tails must come close to alternating in the short run. The coin has no memory. It doesn't know what past outcomes were, and it can't try to create a balanced sequence. Believers in the law of averages think that if you toss a coin 6 times and get 6 tails, the next toss must be more likely to give a head. It is true that in the long run heads must appear half the time. However, the myth is that future outcomes must make up for an imbalance like 6 straight tails. This is the myth of the law of averages. Coins and dice have no memory. A coin doesn't know that the first 6 outcomes were tails, and it can't try to get ahead on the next toss to even things out. Of course, things do even out in the long run. For example, a few years ago, Dear Abby published in her advice column a letter from a mother of 8 girls. After having 7 straight girls, her doctor mistakenly told her that she was more likely to have a boy for her 8th. However, having children is like tossing coins. Although 8 girls in a row is very unlikely, once 7 girls have been born, it is not unlikely that the next will be a girl. The correct way of interpreting a law of averages is through the law of large numbers. The law of large numbers states that in a large number of independent repetitions of a random phenomenon, averages or proportions are likely to become more stable as the number of trials increases. When we say independent, we mean that each future trial does not depend on the outcome of previous trials. In closing, let's discuss a much less scientific way in which the term probability is used. Oftentimes, the term probability is used as a personal assessment of how likely something is to occur. This is called a personal probability. A personal probability is a number between 0 and 1 that expresses an individual's judgment of how likely an outcome is. Personal probabilities are merely opinion and should always be distinguished from probability in the true sense.